Добрый вечер. Сегодня проведем обзор на социальной сети проекта MOAC.io.
Hello everyone, welcome to the MOAC development webinars. This is Zhengpeng Li. I'm the VP of Engineering in MOAC. Today I'm going to give a short introduction about our development tools. The content is as follows. First, I'm going to give a short introduction about our MOAC project. Next, I'm going to just generally introduce the resources we have, including all the web pages and the tools we developed. I will focus on the development tools we have. After that, I'm going to give out two simple demos using the development tools to deploy a simple contract. Okay, let's start it. After that, I'm going to give out two simple demos. MOAC. The development tools to deploy a simple contract. Okay, let's start it. MOAC stands for Mother of All Chains, MOAC. We started this project in January 2017, and we discussed some ideas about how to using microchain technology to finish sharding and to increase the blockchain usabilities. And in the summer 2017, we did a SEO and get the funding for this project going. And this April, we launched our mainnet, mainly the mothernet. Then in June, we launched the microchain. And currently, we're improving the microchain technologies to provide more tools and easier access for developers. Our mother chain was developed based on Ethereum's platform. We call it validation nodes. Just like Ethereum nodes, we have miners in the system which doing the miner work and can get rewards from the block they mined out. We have another roles like a monitor, which just monitoring what's going on in the network but didn't do any mining at all. We have additional tools there. It's called the proxy. The proxy is the vNode that connects with microchain servers like the smart contract servers or SAS, we call it. It will use to communicate with those microchains. The difference between this proxy and the monitors is the proxy can join the microchain mining and it also gets rewards from the microchains. The mother chain, the consensus algorithm, is the POW, just like Ethereum platform. The microchain, we also call it the subchain sometimes. It actually composed of a group of smart contract servers. For smart contract servers, there are different nodes that running the SAS software. It has two roles. One is a miner, which get into the consensus in the microchain and generate blocks. It will get rewards from the blocks they generated, and the amount of the rewards depends on the microchain contracts. Another role is just like monitor. Basically, it won't join the consensus algorithm, but will give out the information about the microchain. The microchain actually is a logical concept. It's called a smart contract of the microchain, which we are going to give more detailed introductions in our later series. Here is the data flow of our microchain system. Basically, we send the TX and deploy contracts, call contracts, use the operations of the blockchains through our API layer. All the API requests will be sent to the vNode, and the vNode will broadcast the information to other vNodes. If a vNode connects with some SAS server, it will send the message to the SAS server only at the local plane. So the outside API or commands, they did not talk with SAS directly. And SAS must register with vNode, and they have to trust this vNode. By this way, we can avoid the DOS attacks between SAS. This is the major difference between the sidechain and our microchain. For a sidechain, basically the nodes inside the sidechain, they can talk with each other. So let's say if you can get into one of the sidechain nodes, you can attack the sidechain easily. But by our microchain, since you cannot directly talk with this SAS nodes, you have to go by this vNode, the mother chain. That gives the microchain the same security level as our mother chain. By using these technicals, we can ensure that our microchain has enough security to protect its users and the data on it. Okay, now we are going to introduce some resources we have. Of course, the first resource is our web page. Okay, this is our home page. Okay, now we are going to introduce some resources we have. Of course, the first there are news and also some updates. There are some introduction information. Also some news about our activities here. For developers, we have the documentation, some videos, and APIs. We also built a website called moacwalletonline.com. This is using the my Ether wallet open source project. We made some modifications of this, and you can see this website has some basic functions like view wallet information. If you have an address here, you can basically input this, and it will show the address information to for our testnet and the mainnet. We have developed another tools, wallet.moac.io. We're going to give more instruction about this in our demos. And this is a great tool to deploy contracts and make some debugging with the contract you have. Recently, we also developed extension based, we call it MOAC mask. This is a smart tool. You can use this one to access a MOAC network. Basically, we have main network and our test network. This was developed based on MetaMask, which is also an Ethereum project. You can see for our project, it's quite easy to move the project from Ethereum to our platforms. Of course, we have this YouTube channel you guys are watching now. We have a lot of good resources here. One of them is an introduction video that's made by our CEO, David. It has a very good information about the MOAC structures and how it works. We also have some videos about microchains. Oh, okay. Well, you guys can always come back and check it later. Yeah. Also, for all the developers, GitHub is something we must use. We use it every day, and this is the main public repository we have. Now we have about 6 repositories here. MOAC core is the repository that we release our major releases here. We publish all our releases here. The latest one is the Firestorm. We also have the wiki, which contains a lot of information, including the vnode. This is the place I will recommend all developers to come and to comment, to use, and to give us some feedbacks. We can some issues here. This is the place I will recommend it. Okay, we already showed the wikis, and also we have the chain 3. This is the JavaScript API we have to connect with our MOAC node. We are going to have a demo to show how this one works. This is the JavaScript API. Okay. For DAPP developments, I think the first thing all the developers need to learn is Solidity, because all the smart contracts we are using now programmed by using Solidity. There are a lot of good online resources for this. What we recommended is the official Solidity document site. Also, if you are a beginner, we have used this Crypto Zombies website, which is pretty cool website. You can learn some basic information, basic programming information through their online courses. You can also communicate with our MOAC chain platform using Node.js and our Chain3 library, which we're going to introduce later. We recently just published a Python library for our Chain3. A Java Chain3 library is also under developing and will be released soon. The Chain3, actually this is the library we use quite a lot at this moment. This one is similar to Ethereum's Web3 JavaScript library. We have this one, the source code published on the on our GitHub repository, and with all the documentations through the MOAC core wiki and through the main code or main website code. This one. Okay, now I'm going to, let me go back. Now I'm going to give two short demos about how to deploy a contract using wallet.moac.io. Okay, now I'm going to, okay, to use wallet.moac.io, first thing you need to do is running a MOAC node on your own computer, which we suggest it for developers. It's quite easy to do this. The only thing you need to know is we have a video on the YouTube channel for this, but when you're running this, just to make sure that you make a smart. You need to make sure you have this RPC course domain included this moac.io. This will just allow this website to access the local MOAC node. This will just allow this website to access the local MOAC node. After you started a MOAC node, you get into this website. It will show you the account you have. And if you want to deploy a contract, it's quite easy. Click contract, deploy a new contract. Then you can choose the account you want to use. Here you can put your source code here. Let's find a simple one. Just a moment. Do the simple contract. It will compiled automatically after you copy the source code here. If the contract compiled successfully, you can see the contract functions show up here. So the contract deploy. But before you deploy, you have to unlock the account. Since we're using this account 1, to deploy the contract, we need to start another. Okay, just showing. You need to attach your instance to this MOAC node. So this is quite similar with Ethereum nodes. Oops. This is quite similar with Ethereum. Price of a gas. I click deploy. You can see this is creating contract. This is doing the confirmation. Okay, we already got two confirmations. Basically, that means two blocks are generated after it was put into the block. Okay, we already got two confirmations. Basically, that means two blocks are generated after it was put into the block. Yeah. And actually, if you open this MOAC node screen, you should be able to see there are some information in the background. Okay, so let me submit it like this. This is the contract address. Yep. So basically, we can use this these simple tools to deploy some contracts and make some and call contract functions. This is quite easy to use tools. Another tool we suggest you to use if you have worked with Ethereum before is Remix. We have another video on our YouTube website show you how to use Remix. It's quite similar to this wallet.moc.io. Next, I'm going to introduce how to use our Chain3 JS library to send transactions. Okay, if you can go to our website, you can clone this Chain3 package. And in this package, we have an example directory, which has several example programs. In these programs, you can find the sendmc.js. Here you can see in this example program, we have this index.js, which you can, if you really call in Chain3, you probably should replace one by Chain3. And we have some accounts here. One thing is the example program we skipped this private key here, because if anybody using this private key, I won't get any test MC here. So basically, okay, we have all the examples about how to construct our transaction object, and then how to use our sign transaction function and the private key to sign this transaction object. After that, you can send the raw transaction function to send to the MOAC, the local MOAC nodes. After that, you can send the raw transaction function to send to the MOAC. This part shows you that you need to set up the provider first. And in this case, in this demo case, we just show this one as a local MOAC node. So for all developers, we really suggest you to try to run a MOAC node locally. If you have any questions, let us know about this one. Okay, to run this quite easy. We really suggest you to try to run a MOAC node locally. If you have any questions, let us know about this one. Okay, to run this. It's quite straightforward. This is the hash we got. And we can see in the background that it shows we send out a raw transaction to the MOAC node, to the system. Okay, here is the attached. Let's see. Oh, it's already finished. Okay. And then we can check this transaction. Okay, it's already was included in a block. Block number is this, and this is block hash. We also have some examples inside the example directory, which shows you how to deploy a ERC20 and how to call some ERC20 functions, and how to deploy a ERC721, or just to show some node information using our chain3 library. Okay, that's the two simple demos we have for today. We are going to provide more information in later seminars. Now let's see if anybody has some questions. We are going to provide more information. Okay, let's see. In later seminars. Oh man. Now let's see if anybody has some questions. Okay, it seems I messed up some screen size here. Okay, we will worry about this one later. Just see if anybody has some. Let's see if anybody has some questions. Okay, we will worry about this one later. Just see if anybody has some. Let's see if anybody has some questions. Okay, here this I got this question here. How can MOAC achieve 1,000 times higher TPS than Ethereum? We did this mainly through our microchain. Okay, here this I got this question here. Using our microchain, we can easily finish sharding techniques, for which is already pretty faster than Ethereum. If we have 100 microchains linked to our system, it's easily to get 1,000 times higher TPS than Ethereum. If we have 100 microchains linked to our system, it's 1,000 times higher TPS than Ethereum. Okay, why is MOAC called the mother of all chains? Where does the name come from? Well, this is really comes from when our founder, Mr. Shah, we have this discussions several times about how to use this microchain ideas. And then he said, okay, since we generate all kinds of microchains, and it's kind of like the mother is taking care of all these microchains. So why we call it just the mother of all chains? Because in our design, we really want each microchain to have its own functionalities. It can have its own consensus algorithm. It can have its own functionalities, like the one we just released recently, the Firestorm, which is a microchain that has the IPFS function. We're also developing a microchain that has the cross-chain functions. If you want, you can develop microchain with its own its special functions, because the microchain we have here actually is a smart contract. If you go to our website, you can see we have some subchain listed in our release site. Let's see. If you go to our website, you can see we have some subchain. See, for this Firestorm, we have this two smart contracts, which really generated the microchain. See, for this Firestorm, we are going to cover this area in later webinars. And for all these smart contracts, they are written in Solidity. So if you are Ethereum developers, it will be easy for you to take a look and to understand what we are doing here. If you are new developers to blockchain, we suggest you to go to study some Solidity to understand how the microchain works. To understand how the microchain works. Okay, here is another question. What's the difference between a microchain and a sidechain? Okay, in our design, as we pointed earlier, here is another question. What's the difference between a microchain and a sidechain? A sidechain, basically, it allows all the nodes inside the sidechain to talk with each other and connect to the main chain through probably a centralized a node or several nodes. But the major difference here is the sidechain, the node inside the sidechain, it directly talk with each other and it know each other. So let's say if there's an attack to one of the sidechain nodes, it can attack the whole sidechain and break it down. To prevent this, we made this microchain design that all the attacks has to go through this V node to pass to the microchain. So basically, for each, if you can attack one of the node, it's basically just attack the mother, not the microchain directly. So basically, for each, if you can attack one of the node, it's basically just attack the mother, not the microchain directly. So for our microchain, the security of our microchain is the same level as the mother chain. But for a sidechain, usually it has less computing power or less nodes, or we should say less security than the main chain it connects with. But for a sidechain, usually it has less computing power or less nodes. This is the major advantage we have for the sidechain. This is the major advantage we have for the sidechain. Oh yes, another question is explain the sharding system. Well, we don't have a very good graph here, but I believe we have a video in our main website. Yes, another question is explain the sharding system. This is more explanation in our it's basically made by our CEO. In our main website. Let's see, playlist. This is more explanation in our. It's basically made by our CEO. Boom shakalaka, what's going? Oh no, not this one. Okay, let me. Okay, we can just take a look at this sharding. I will try to use this simple graph to explain this because we planned to explain this sharding system in our microchain series. Just a short explanation here. For each microchain, it will run it has its own consensus algorithms, and it run its algorithms not depends on the main chain's consensus progress. So basically, when it received some transactions or information from the mother chain, it will run its consensus only inside the microchain. It won't affect the mother chain. It won't affect other microchains. It only runs the consensus with the nodes inside that microchain, which is included by the smart contract defined by the microchain smart contract. So through this, the main bottleneck of the mother chain won't impact each microchain, which composed of a sharding system. The main bottleneck of so let's say one microchain is processing some smart contract which requires more time, but the other microchain could just process very different transaction and a totally different smart contract. They are not going to interface with each other. But in the Ethereum system, if you run two smart contracts, just like we have seen in the Ethereum system before, when people are playing the crypto kittens, they're sending a lot of transactions and waiting there to be put into the blocks. But in our systems, basically, if you play crypto kitten, you can just run the crypto kitten microchain, which all the transactions will be sent to the crypto kitten microchain. And let's say if you run another crypto dog or something, it will just run to that crypto dog microchain. It won't interfere with the crypto kitten microchain, and each microchain run by itself. When they run to a certain stage, they're going to flush their results back to the mother chain, but only after 100 or 200 blocks. You can define that in your own microchain contract. So through this, we can we can separate this transaction sending to the system to different microchains and let them process independently. This is the way we finish sharding. We can separate this transaction sending to the system to different microchains and let them process independently. This is the way we finish sharding. Okay, we have one more question. How can we achieve the cross-chain functionality with MOAC? This will be done through a set of special microchains. We have one more question. How can we achieve the cross-chain functionality with MOAC? This will be done through a set of special microchains. I think I probably should put more information about this microchain stuff, because we have a smart contract as a microchain, which when you define a microchain, you can define the functions inside for each SCS to work. We have a smart contract as a microchain, which when you define a microchain, let's say we want to send out a cross-chain to another blockchain, let's say maybe just Ethereum or Bitcoin. To do this, you have to have smart contracts that can handle the other blockchain with it, with smart contracts that can with our microchain. Well, let's say. So this requires some different programming with our microchain. Well, let's say. So this requires some different programming designs for the SES nodes. Basically, it will get the transaction from the other blockchains, then writing the microchain blocks that are generated inside the microchain. Actually, write the status there inside the microchain. Then, when the SES nodes they generate this consensus inside the microchain, it will automatically generate the transactions that the other blockchain defined. So basically, to do this cross-chain, the other blockchain also need to support some kind of smart contract. Otherwise, it will only be able to do simple transactions, like maybe a token transaction. Smart contract. Otherwise, it will only be able to do simple transactions, like maybe a token transaction. Yes, there are English tutorials on our YouTube channels about how to build a smart contract using the microchain. Yes, there are English tutorials on our YouTube channels about how to. Let's see, we have this. see what if they have already. And we are going to provide more details in later series in these webinars. And we are going to provide more details in later series in this webinar. Okay, connect. Okay, this is a video that made by our CEO David. It gives more detailed explanation about how the MOAC system is structured than today's video, because today we're just focus on how to use a general introduction about the development tools we have and how people can use it to deploy some DPP, some smart contracts into our system. In this video, online training development blockchain applications is a little bit longer. It's about 1 hour and 30 minutes. But David gives more detailed introductions about how to create those microchains. Yes, there are okay, here, this is another question. Are there any projects running on microchains? Now, yes, we have some projects running on microchains. They are mainly on our testnet. We haven't moved to the mainnet yet, because basically these projects we're still doing testing our microchains and want to make it have better performance. We have done some pressure tests last week, and we figure out some issues we can improve to optimize the microchains performance. We can achieve in average network conditions, we can achieve over 100 TPS for a microchain. And I believe we can improve that one more in the future. Okay, how come the MOAC code is not completely available on GitHub? Yeah, one thing is we are still developing this codes, and well, this is just to. There's something where we're a little concerned about some teams. They probably will misuse our codes for yeah, we're talking about how to releasing the code after we fully tested this, and release it after we get a more stable version. Release it after we get a more stable version. And for the DAP developers, we really would like you guys to help us build our ecosystem. Like in our MOAC chain main repository, we have our chain 3 is fully open, is all open source. This MOAC TX, this is actually to you can use this one to construct a raw transaction and send to connect with our main chain. For the MOAC mask, we also release the code here, and you can use this one to play it around to make something like this is extension tools. We are still developing this, and we are going to including the functions like including the microchain access and showing more information here. Well, let's say if you really want to work with our platform, the coding for the mainnet platforms like our Filestorm or this vnode code here, you can send us email. Let us know. Yeah, we're happy to have more people to join us and develop this ecosystem. Yeah, we're happy to have more people to join us and develop this ecosystem. Oh, here's another question. How do you feel about the token price? Have you guys had to take action to control the price at a certain level? No, we didn't do that. Yeah, we get our funding last summer, and I believe we didn't use any funding we raised to control our token price. We know there are some teams that we did that, but we didn't. We put most of our fundings into our development, including our platform development and our community development. We didn't. We know. Yes, everybody is seeing the big price drop of Bitcoin and Ethereum. I think this is. We're expecting this, honestly, because we see last year's price rise of Bitcoin is really not rational. And there are too many bubbles there. And a lot of people, they didn't want to do a good project. They just want to get rich quick and get out of here. But we really want to do something. So we didn't care much about our token price. And we believe as long as we're working hard and make sure it's working of our platform and getting more projects coming in, our token price, people will know that. People will use it. As long as we're working hard, make sure it's working of our platform and getting more projects coming in, our token price, people will know that. People will use it. Oh, we plan to. The question is, how often are you guys going to have these webinars? Our current plan is to have these webinars about 2 weeks. But of course, if people want to have any information or have more requests about, let's say, if people want to see how we develop on microchain webinars, we are going to do more frequently. Or have more requests about, let's say, if people want to see how we develop on microchain webinars, we are going to do more frequently. Yeah, I see that. Yeah, the screen size. I didn't notice this. This is the first time I use this one. Yeah, I probably will put another version later about using the right screen size. Yeah. Yeah, I probably will put another version later about using the right screen size.
听完了吗？这灯一定要关，没人听。啊？我这里面没人关，不需要你。你经常就浪费电，那地方都没人。睡觉了哈，不看别的。这两年洗澡了，就随便的泡人。
Oh, okay. For the next topic, our plan is to focus on the mother chain. But if people are interested, maybe we can switch it to using microchain, or we can put it into Firestorm's microchain. People are interested, maybe we can switch it to using microchain, or we can put it into Firestorm's microchain. Okay, there's another question. How do you guys going to build an enterprise-grade platform? Seems like a daunting task. Yeah, that's I agree. That requires a lot of work, especially from those professional teams here. Well, our current plan is to make our microchain more stable and have a better performance. We currently are working with some companies to test our microchain, and since our microchain is kind of like smart contract based microchain, people could improve their microchain through this. Basically they can use their smart contracts and our SCS softwares to get into better performance. Then can make them into a more standard product. Let's say maybe a POS subchain, microchain, or a microchain with PBFT. Then can make them into a more standard product. Let's say maybe a POS subchain, microchain, or a microchain with PBFT. Okay, I see. I'm hoping you can explain the tokenization a bit more too. Instead of just the tokenization here, actually we bring on some ideas just building a microchain using our system. which is what we're working on. So for, let's say, in SRAM systems, you are just issue a token, but here actually you can issue your own blockchain, which, let's say, that's really make it much easier for teams to try their ideas. They basically don't need to build their own blockchain systems. They can just using our system to run their idea, to test on their ideas, to see if it works on blockchain, and if it works, they can just move this one to production quite easily. Run their idea, to test on their ideas, to see if it works on blockchain, and if it works, they can just move this one to production quite easily. Okay, what about the mining system? Our mother chain's mining system is just the POW, like SRAM. For each block we have about 2 MOACs we can mine out. This will be reduced in about 3 years based on the block number, and after that will be reduced again until we get about 6 years. We describe this in our white book. But for the microchain, you can define it in your microchain smart contract. Currently, we have a POS a microchain already been built up, but you can define your own. You can define it in your microchain smart contract. Currently, we have a POS a microchain already been built up, but you can there's a question about how much TPS on microchains when you guys test and when on mainnet. For the microchain we tested, we have there's 2 conditions. One is just inside the lab. Basically, you have a very good network connections. Also, that's much higher. But we tested on our testnet last week, and that's really we met some issues here about the network, about the cloud servers we rented. Then we figured it out and we optimized that. It's basically in average network conditions, we have this one over 100. Yeah, but it could be more. It just you need to, let's say, get a good cloud server and increase the bandwidth you used. We cannot say how high. That really depends on the system. But at this moment, we can say 100 TPS for our microchain. For the main chain, we have tested it in April and May. Our system can reach about 10 times of what Ethereum did now. That's around 200 to 300 TPS. We have tested it in April and May. Our system can reach about 10 times of what Ethereum did now. That's around 200 to 300 TPS. Okay, there's another question. Can you explain how ATO can solve the problem of ICOs? In our design, we hope that instead of just issue a token represent your share in the new project, we really want some real asset based on those tokens. I think one question about this ICO is as soon as people finish the ICO, they want to sell their token, and they were done, and they get rich, and some people will quit, and only small fraction of people who really want to do some things, probably like us, will stick to it. For in ATO, since this one will be the token won't be released that fast, and that will let people stick on their project, and their token price will increase as their project improved. hopefully by this way people can focus more on their project and can do some really good and interesting projects. Then more and more people will be getting involved, and then can increase their token price. Then they can get rich later, not just as the finish of ICO they get rich, then they gone. Hopefully after 1 or 2 years hard work, they get good about their token. They get good asset about after their tokens, and they can be rich then. Hopefully after 1 or 2 years hard work, they get good about their token. They get good asset about after their tokens, they can be rich then. Okay, thanks very much for everyone who come to the webinar. And thanks very much for your questions and for your interest. Please be sure to connect with us and join us to build a better blockchain. Come to the webinar. And thanks very much for your questions and for your interest. Please be sure to connect with us and join us to build a better blockchain.